Guys, you know this stuff we've been using an awful lot of, haven't we? It's hand sanitizer, right? It's a solution. It looks like one thing, but look, if you look in the back, there are tons of ingredients, right? It's not just one thing. There's propanol in it, glycerin in it. There's a whole bunch of stuff I can't say, but there's some form of acid in it, and there's purified water in it. So this actually just looks like one thing when it comes out, right? And at the molecular level, which means at the very bottom of the level, right? Ew, let me just rub that in because I really want more on my hands. It's one solution. So today our focus and learning target is, I understand a solution is a type of mixture with a solute and a solvent. So we have been talking about different types of mixture. Remember, we talked about heterogeneous mixtures, and we also talked about homogeneous mixtures, right? Homogeneous mixtures look like one thing. Heterogeneous mixtures look like more than one thing. Now that you know the two types of mixtures, we have to talk about solutions, where something dissolves in something else. So here's our first key term today. It's solution. Say it with me, solution. A solution is a homogeneous mixture that looks like a single substance and has the same properties throughout. So some examples of solution might be salt water, air, carbonated water, right? Water with bubbles in it, rubbing alcohol, gold. So something that looks like one thing. Another solution would be, of course, the hand sanitizer, liquid soap, detergents that you use in the laundry or to wash your dishes. There are all kinds of solutions. But in a solution, you usually have something dissolve in something else. So here's our next term, dissolve. Say it with me, dissolve. It means to cause a solute to pass into a solution. You might think this word looks like solute, like, ta-da, I respect you. No, solute. Say it with me, solute. Okay, so a solute is the substance that is dissolved. So if I'm going to put sugar in water, the sugar is what dissolves, and so the sugar is the solute. If I'm going to put salt in water, the salt dissolves. It's doing the dissolving. It is dissolved. The salt is the solute. Well, so what do you call the other part of a solution? You call it a solvent. Say it with me, solvent. So solvent is the substance in which the solute is dissolved. Now, I bet you can just think about the liquid that I just told you dissolves salt and sugar. So that would be water, right? So water is called a universal solvent because all kinds of things dissolve in water. As you might recall, I just told you there was water in this, right? There's water in detergents, there's water in juices. Water dissolves a lot of stuff. Most of the time you can just put water on something and it dissolves. Okay, so it dissolves a lot of stuff. So on notebook page 53 today, I'd like you to describe what is the difference between a solute and a solvent in a mixture. You're going to watch a couple of videos. And what substance is considered the universal solvent? I literally just told you, so I'm hoping you're watching the video. Pay attention. Today, we're also going to do notebook page 54. Notebook page 54 is short as far as notebook goes, but it says, I can identify factors that affect how fast a solid will dissolve. So today, this is awesome. We have 3 labs to do. You're going to do 3 labs, but you're going to submit the questions from the labs on one Google form. So you need to do them, and then you need to write down what you found out or what you learned, and then you need to respond on one document. And of course, it's an assignment, so you only get one opportunity to complete it. So we are going to actually dissolve some stuff, right? So factors that affect how fast a solid will dissolve are mixing. So if you mix something, you're stirring it, you're shaking it. If you heat something, particles break apart more easily. Like particles are attached to each other from molecular bonds, right? But if you heat them up, it speeds them up, and their bonds become a little bit more weak, and they start to separate, so they break apart more easily, and they collide more often. So if you heat something up, it's easier to dissolve something. If you crush it, so crushing increases the amount of surface area and contact between the solute and the solvent. So I don't know if you've ever experienced that, but if you put an entire cube of sugar in a cup, it will take like 1.5 minutes, maybe 2 minutes to completely dissolve. But if you crush it up and put it in the cup and stir it, so you've increased the surface area, and so like particles can collide with more particles in the sugar, and if you stir it, you speed up the collisions, and you have a speeded up dissolving. So today on page 54, I'd like you to list 3 to 5 examples of solutions, and I'd like you to describe what you learned in one of the labs. You're going to do a lab called More Mixtures. In this one, you're going to look at a mixture. You're going to describe whether it's homogeneous or heterogeneous, and then you're going to look at the weights and the masses and the volumes and determine which one might be a solute or a solvent, okay? And this one you can do with video, okay? Or you can do it in person if you want, but it's pretty easy to do with 3 really short videos. Then you're going to do something called sweet solutions. You're going to put M&Ms in your mouth, just one at a time. The first time you don't disturb it, right? So you time how long that takes for the candy shell to dissolve. At the second time, you put another one in your mouth, and you're going to time how long it takes the shell to dissolve on the outside. If you just use your tongue, you're going to stir it in your mouth, right? So your saliva is going to act as the solvent, and the sugar and the candy shell is going to be the solute. And then you're going to do something called the rate of dissolving. And you'll have to watch a couple of videos to do this one and make some observations. You can either time them, or you can just make observations so that you know how things in a solution, how fast they will dissolve. And you'll look at mixing and heating and crushing. And there's some great videos for this. So you're going to have to answer the questions in the labs, and then you're going to have to submit the answers for all 3 labs on one Google form for me. All right, actually today is a pretty long lesson, but it's the last lesson we're going to do with compounds, mixtures, and molecules for this unit. Our next lesson will be a study guide and a review, and we'll talk soon. So stay on it, make sure your notebook's up to date, enjoy the videos, see if you can't figure out how to do the labs. You really don't need supplies if you don't have them. Just watch the videos, and then I will see you next class after you've done all of these labs. And don't skip the videos. They help. All right. Have a good afternoon. Be sciencey.